So either way, there's no...
Well, no, actually, you should multiply it out. I'm just saying people have been getting confused with stuff like this in other questions. So the better really is to multiply it out first. So you do 20 minus 10 by 1 is minus 10, and minus 10 minus by minus plus 10 e to the minus 2t, and then send it is what you should really do. You get the same answer. That's multiplying out now and send it. Alternatively, send it and then multiply it out.
Is there, do you know, even you said you're adding together, you can do individually.
Yeah.
You can do those individually as well, yeah? Even though they were multiplied out.
No. You fix the constant though.
Okay.
Like you fix this constant, but this constant isn't multiplying by something. So you just set that.
So that 10 definitely isn't over S, like?
Definitely not. So really, like that confusion, it does make confusion. Multiply out first, you've no confusion. Now, that 10 doesn't get sent to 10 over S, does it?
No, it's
Because it's multiplying. This one will.
That's what you're saying, yeah.
And you may say, well, where's the 10 over S down here? We'll multiply this out, you'll have 10 over S.
And you'll have minus 10, 1 over S plus 2, yeah?
Say again?
Minus 10, 1 over S plus 2.
No, plus 10 over S minus 2.
Oh yeah, that makes
Sorry,
sense.
plus 10.
Yeah, so of course the easiest, I say multiply this out, of course what you should do then is 20 minus 10 is 10. And then send. Otherwise you'll have 20 over S minus 10 over S, which is a bit stupid. That is equal to 10 over S.
It should be minus, sorry no, but that should be S minus 2, shouldn't it? 1 over S minus 2.
No.
Because it's to the power of minus 2, e to the power of minus 2.
Yeah, the minuses come back to, or go to pluses.
Oh, do they?
Look at your tables,
Oh,
yeah.
I didn't know that.
Tables, that's right.
I'll check tables there, that makes sense.
Now, so this, if you are kind of skirting the harder stuff into the class, you still want to be able to look at it and say that it's hard. If you can do that, that's kind of great. Although to be honest, most time when you can appreciate that something's harder, then you might actually be able to do it after all. So, why is this one hard?
It's multiplied over.
Multiplied them. They're multiplied together. Right? And this one, there's no product rule except for kind of one thing. So you look in the tables, look in your tables, where is this yoke? Yeah? Yeah. So this is the first shift theorem. Go third from the bottom. This is similar to f of t times e to the minus at. So how do you send it? This is just the first shift. Now the first shift theorem we did earlier was coming back. That's actually the hard one. This is supposed to be kind of easier. It says send it away, but then shift the s to s plus a. So send it away to f. So f is the Laplace transform of this. So this yoke is called h, is it? Little h of t. So this gets sent to big H of s. So if the s is shifted, you're coming back, you're multiplying it by an exponential shift. If you're sending it forwards, as it were, and you're multiplied by this, this is a shifter. Or this is a shifter. So you just send this for a second as normal. So what does sine 3t get sent to?
3 over
S
Go
squared
fish.
plus 3 squared.
Go again. Oh yeah, sorry. 3 over
S plus
s
S
squared
squared plus 3
plus
squared.
3 squared.
Go fish, so.
But this guy is a shift, so it's going to change the s
Plus whatever.
s plus 2. That's it. Now, like I don't know if people are able to see. Like, say now, if you're somewhere in the middle and you realize it's hard, and you know it's the first shift theorem, but you can't quite get over the line. If you write that this is the first shift theorem, I'm giving you marks, but I mean that's a big marks. It does the opposite of annoying me. Yeah.
Wait, sorry, where did that plus 2
Does
come
it
from
even more
again?
than
No, no, minus 2, please.
Go ahead.
The plus 2 again, where'd that come from?
This,
Negative 2
so
digit.
this guy, so in the tables, this guy is sent to, if it's a minus A here, send it as normal, but the S gets shifted to
Oh,
S
yeah,
plus.
yeah.
So the minus goes to plus. And if that was a plus, like back here, if this was a plus, this would be a minus. So that's them.
Is that the answer, yeah?
Yeah.
Oh, yeah.
And then the last one, I think, for tonight. Is this one on the test?
Yeah,
Yeah. Quiz, yeah.
that's the 50 minus 50, but.
Yeah.
Doesn't
So
seem
I'm
to
going to send a few more to you,
do you?
which kind of theta's for pendulums, theta's for temperatures. Well, to be honest, in a way I need them because they're all done in full abstraction in your notes. Actually, I might just tell you what pages in your notes to look at. That might make more sense.
Yeah.
I don't know. Now the two, oh no, I will send you the critically damped. I'll send you one. Now this isn't the door closer, obviously. There will be some story. So this is charge in a capacitor. So the first yoke change of rate of change of charge, that's current. So this is current plus something times charge is equal to something. I can't remember what this is exactly. I know it's a charging capacitor. That's got it. Now, what doesn't change from earlier on is you send everything. What we might write down is, what is the role of F being played by here? Q. Small q. So, looking at your tables, dq, dt, which thing in the tables is this?
S, Q, S.
Minus small q, O.
Yeah, so the second bottom. So derivative is sent to S, big Q of S, minus little q of 0. Fix the constant, because it's multiplying. You can call it 0.1 if you want. What's little q of t sent to?
Q, PQ,
Big Q of S. And this is why I kept sending that 0, because 0 gets sent to 0. 5 doesn't get to send to 5. What's 5 sent to? So that's the first step. Now your job is to do the initial condition, which a nice one here is the plate is initially uncharged. That's gone. And now I want to solve for Q of S. So I have 2 Q of S's, so I've got all the Q of S on one side. So what am I going to do, please? Take out the common factor Q of S. That's an S there again. So take out the Q of S, I get an S plus 1/10 equal to 5 divided by S. How do I get rid of that S plus 10th? Divide. So I have Q of S is equal to 5, it's divided by S, also divided by S plus 1/10. Okay. I look in the tables. Now, like you're doing well if you understand. Okay, so if you're talking in the same way, why is this not so easy? They're kind of multiplied together, so you need to spread them out. How do you spread these yolks out? Huh?
S plus 0.
Find the factor. It's already done. What's the thing we call cover up method? But even before that, partial fractions. And the first step in partial fractions is factorize the bottom. Done already. So now you look at the rules. Now this is, which one is this? What rule is this definitely? Rule 1. Now some people are a little bothered by S on its own. Could you write S as S plus something?
That's 0.
S plus 0. So it is a rule 1. So if it's 2 rule 1s, you can do the cover up method. Now. So I'm going to have something over S plus something over S plus the 10th. And this is the other one that catches people. When is S equal to 0? 0. When S is 0. Right? So cover up this and put S equal to 0 into all the S's that are left over. First we have 5 over 0 plus a 10th. I'll just put in 0.1 there for a sec. And then when is s plus a tenth equal to 0? No.
No, so what, you put in an S there, or is that a Z for 0 or what?
This is a 5, this is an s.
Minus s minus a 10.
Oh, that was stupid. Sorry. It should be 0, yeah, sorry. When is s plus a tenth equal 0?
Minus s minus a 10.
Minus s minus a tenth?
Minus 10.
Minus 10, yeah. So I have covered up
That's fine.
5 over minus a tenth, which again I might just write in as minus 0.1.
Fucking marks for nothing.
Yeah.
That's few were
So 5 divided by 0.1 is 50 over s
negative.
negative, so I can take out the minus 50 over s plus a tenth. And then what? No, this is going to be sent back to what's big cube s sent back to? I know 50.
Small
I'm
cube
going to
t.
call it
Small QT.
small cube t. This sends back to 50. I can fix the 50.
You're not going to dock us in tonight's quiz for that small QT there, no, because you said it after the quiz.
No. And I could be, yeah, you're definitely back, but I mean, one of them marks are absolutely nothing. S plus a tenth, 1 over s plus a tenth.
E to the negative t over 10.
That'll do me. Or I can do tenth of t or minus 0.1 t. And then the other part of that, what is the behaviour of cube t for large values of t? Well, 50 is just 50.
This gets closer to
50. This guy goes to 0. Doesn't it? Yeah. And obviously, what does that mean for the capacitor?
This gets closer to
It's charging. Yeah. What caused the capacitor to go? I can't remember this. Just from memory.
Discharge.
Yeah. Do you have to do something?
Lower than.
You just put a low. Short circuit and
Short circuit.
plus minus.
Make it.
And discharge, right? For the whole cell to charge.
Okay, so that's half. That's 50%, and then you'll have a choice after that. And I think you can make that choice pretty much before you go in.
Yeah. Don't do 3.
So if I'm looking at this 2, yeah, you can. I mean, a lot of people saying don't do 3. For me, I think 2 is the hardest question. I think do 4. So
Is it going to be this, like, question 2 and 0, it's going to be the same 20 questions?
roughly, like say now, that's a harder derivative. It might be a hard derivative like that. It might be 3 easier ones. There's definitely first principles. There's definitely inverse Laplace transforms then. So similar layout, not similar questions.
But you could also get something.
What else?